All right, guys, so no new formulas today. We're still working with area of a circle, but this time we are going to be really specific about how much of the circle we're interested in. So I'm just going to go right into examples and show you what I mean here. So for the first one, we're not interested in the area of the entire circle. We're only interested in that yellow part, that sector, that part that's shaded there. So problem is I don't have a formula for that. I don't have a formula that just gets me an area of part of a circle. So I'm going to start with what I know. I know the formula for the area of an entire circle is pi r squared. So let's just start with that. I also have a radius of 20. 20 squared is 400. So this is the area of the whole circle. All right, well, that'd be great if that's what I wanted, but that's not what I want. I only want the area of that yellow part, that fraction of a circle. So we just need to figure out what fraction of the circle is represented in that yellow portion. All right, so to do that, I have to recall that all the way around the circle is 360 degrees. Okay, which that would be great if I wanted the area of the whole circle, but I don't want the whole area. I only want 45 out of 360 degrees of the whole circle. Little bit of adding, subtracting, multiplying there, a little bit of multiplying and dividing, and we get 45 times 400 divided by 360. That's a big 50. And that, centimeters squared, is the area of just the yellow part. Okay? So again, the general idea here was find the area of the whole circle and multiply that by the fraction represented in yellow, the fraction that is shaded. Okay? Well, the problems can get a tiny bit more difficult, like this one, this next example. Again, I only want the area of the shaded region. Now, before we just like jump right into it and start looking at formulas, let's come up with a general plan. What's your general plan of attack? Well, I only have area formulas for whole big giant objects, right? So what do you think about this as an idea? Let's go ahead and find the area of the whole circle. All right, so let's find the area of the whole circle. Let's do exactly what we did up above. Let's multiply that by the fraction that I'm interested in. I'm going to say the fraction in blue, because that's going to get me all of this. This whole part right here, this whole thing. Okay, so that little formula I have so far is going to get me that whole thing that's in blue. Problem is, again, that's not all that I want. I really only want this part. So I need to take away the area of that blue triangle. That'll leave me with the yellow stuff that I started with. All right, so now that we've got a plan for attack, let's start throwing some numbers in here. Area of the whole circle, so that's pi r squared, so it'd be pi times 4 squared. So there's the area of the whole circle, times the fraction in blue. Well, this angle measure is 90 degrees, so that's 90 out of 360 total all the way around, minus, now I'm going to take away the blue triangle. So let's see, formula for the area of a triangle, I'll write that over here. That's 1/2 base times height. And if you remember, the base and the height have to form a 90-degree angle, right? So it looks like this is my base and this is my height. But they're both also radii to the same circle, so that means they're both 4. That gets me 1/2 of 16. That gets me 8. So the area of my triangle is 8. Now it's just a matter of grabbing a calculator and doing some computations. And that guy over here. Okay, so that gets me 16. 4 squared is 16. times my 90 divided by my 360. That gets me 4 times pi. All right, so that whole first part is 12.566. All of this is 12.566. And then minus 8. And of course, that's 4.566 centimeters squared. So it's not that these problems are like impossible, it's just you have to come up with a plan before you just dive into it. You got to come up with like, how am I going to get just that shaded region? And what we decided this time is to do the area of the whole circle, but we really didn't want the whole circle, so we got this sector here, this whole big giant sector. But we really don't want the whole sector, so we took away the blue triangle, and that left us with the yellow part. That was the general plan. It's all about coming up with a general plan. Let's look at one more. I'm guessing this general plan might be a little easier to wrap your mind around. You got a donut, basically, right? So I'm thinking that for a general overall plan for this, let's do the area of the big circle minus this white part in the middle, which would be the area of the small circle, and that'll leave us the yellow donut. All right, well, let's have at it. So looking at the big circle, that would be like this whole big giant circle right here. But we notice that their diameter is 14, which means that the radius has to be 7 pi r squared. For the small circle, the radius is given, it's 5. Looks like we've got 49 pi minus 25 pi. Grabbing a calculator, 49 minus 25, that's 24 pi. And, you know, you can leave it that way. Whoops, I need a unit there. Sorry about that. Centimeters squared. You can leave it this way, or if you choose, you can go ahead and multiply 24 times pi on the calculator, turn the whole thing into a decimal. It's completely up to you. And really, it's up to the directions, so just make sure you follow directions. All right, so with these more difficult area problems, you might also want to just review how do you change radians to degrees, degrees to radians, and circumference. You might want to review a little info about circumference, maybe some vocab. Just kind of go through all of your notes from this little circle unit, look through those things, and make sure you feel pretty good about those before you come into class on Wednesday or Thursday, whenever you have class. Because you know, you're going to be doing that open notes, kind of in-class quiz sort of thing that will be graded for accuracy. So you definitely want to, you know, at least look over some stuff to make sure you're ready for that and you're not wasting time trying to look stuff up during class time. All right, guys, good luck. Have a great night.